Okay, about Termite-Nest plugin, you can find it in Food4I know, and as you see, there are two versions. We indicated in emails to all of you that the newest version is the version that we are now working on, Termite-Nest version 1.0.0 beta 2. So you should download this version, and after extracting the files, you have component folder that it consists of Termite-Nest GH-Python. You have to copy and paste this GH-Python file to your component folder. And also there are user object folders that are in the extracted file, and you should also copy and paste these files to your user object folder. And then you should have these tabs for Termite-Nest. If you have all these components, it shows that your Termite-Nest plugin has installed correctly. And also it has also some subparts that Mr. Tabari will introduce these components for you. Yes, it was just, I wanted to get sure that all of you have installed Termite-Nest correctly.
So it seems everyone has Termite-Nest and already familiar with Grasshopper environment. We briefly talking about the space syntax and three main components of our graph networks. So everyone have this file, and we don't have any problem in file opening. Okay, so in this file, we're going to talk a little much more about the graph and the space relation. Before we start, I just want to introducing this the category that we are working on. Termite-Nest actually consists of three main parts, which we are going to talk about much more in next days. But today we are specifically trying to working with the graph. Yeah, we have a new mission. Specifically working with the graph networks and the ability and the things that you can do with with this component, and the ability that gain to you, and the field of implementation. So we talk about the graph maker and the space syntax, and we know that the graph maker is load the CSV uploaded file and create a graph for us, and we can controlling the space, the starting a space here and generating the roots here and starting our calculation. So here we want to talk about a little more complex plan. This plan contains 15 spaces, and you can see that this graph is a little much complicated than the other one we talked in past. So here you can see the space syntax and organized graph, and the things I want to talk about is here in this folder. The data that comes from the graph I told you that the selected tree represent the roots and illustrating the roots that the graph calculate for us. So we can use it in so many ways and just not use it to calculating the space syntax. For example, in this example file, I'm going to show you how you can generating the graph inside the plan and analyzing the relation and the integration spaces. So, excuse me. Okay. So where was I am? Here, to doing this, we need to organizing points within the plan, which are in order same as our space indexes. I'm going to show you the uh, um, index points here. You all have the you are all have the file open in front of you. Yeah, okay. So if I connecting this preview, you can see the points here are organized as well as the rows of my spaces in the Excel file. And this is really important because if it's not being the same, the graph may connect correctly. So firstly, you need to setting points as spaces inside your plan. Excuse me. Here. And then these points can be easily organized and connected to each other within the selected tree that comes from the graph. So the only thing you need to do is to arranging them and selecting them by the list item. You know, understand, are familiar with the list item component in the Grasshopper. I asked it before I started because I want to know how much you're familiar with the list array and the tree object in the Grasshopper. Is it clear in how we can selecting the points here and arrange them in the different parts, different trees? Everyone's are okay with this? Okay, no question? Okay, let's go ahead. If I can connecting a panel to this, you can see it classifying the points we are located here in the trees that are show our roots, and then we can easily connect them together with a polyline interpolated curve. And this moving, which is here, is just to having a little difference in the Z direction to show the lines in the top view to not being behind of the surface. So after that, we can exploding the produced lines into segments which are represent lines for us. So the tree branch here is representing of the target point for us here. So we define the starting point here. I defined my start point as the 0. What was that? Okay. I set the starting point 0, and I want to checking the roots in the plan. So I want to go from the space 0 to space 2. I set it to 2. it's representing the route for me, and that how we can reaching the space 2. So if I going ahead and do it for all the spaces from this space 0, it records the routes for me, and assigning a number to it, and then and then it's ranking the most used routes to show the high integrated routes for me. So I'm doing it one time to see it. To see this, you can see that as I change it, it's getting higher value, and it's representing the level of integration to me. So it could be really helpful when you are trying to analyzing a plan, for example, in school planning or healthcare planning, and some plan with high functionality. So you can analyzing the graph that you created inside the plan. For example, you have and checking out the ability of and the efficiency of the relationship that you provided in the plan. So if anyone have any question about this part, please ask me to uh, talking much more about it. No one does not have any question. Everything
I
is
have one
clear.
question. I have one question, but not regarding to this, so I'll wait until you get
Okay.
to the part.
Okay, ask your question.
Okay, I was trying to use the definition that we used before the break. So to see how to change the relationships between the spaces. I was doing that on the CSV file, but when I saved it and then I reopened it on the definition, the relationships didn't change, not in the Rhino display. If I understand right this definition, that all the relationships are going to be changed on the Excel file in the relationship column.
Yeah.
But when I tried to make that, saved it, and then open it again, it didn't work. Can you show us in this example that you're making only one change of
Yeah. I will
relationship?
show you. I will show you here.
Thank you.
You're welcome. So here is the. Let me just change this display color. Okay. I'm going to change the relation here. I'm showing how it changed. The user relationship Excel is here. Is this one? Okay. For example, the corridor or the entry, I'm going to change this. Which one is the living room is 12 and 9 is the bedroom. Okay. I'm going to detaching the corridor, detaching the living room and the bedroom from this, and adding, for example, space 9 to this, and 15 and 13. I want to check it how it's work. Save this. So let me change. You see that how it's work for me. Kitchen, living room to corridor. Why it's not change? I think the change should be much more sensitive. Let me just change it to the space 14, for example, and here I'm going to change it to space 5 and 6. You can see the graph is already changed as I changing the relations here, and the space hierarchy is also changed, but the differences is not really huge because it's calculating the space depths. As if you remember the last file, we have one space in the depth 4, but we have 6 spaces in the depth 4 now, and the graph is also changed. Is it okay?
Okay, so the method is going to be just changing the relationships on the Excel, then save it, close it, and then open it again, right?
Yeah.
Okay. Thank you very much, Mohammad.
You're welcome. So it is okay. So we are going to talking about we talk about the space syntax, and we are familiar with the space hierarchical by the time. We're going to continue our works and talking much more about how we can now put them together and creating a form with it. And we are going to talk about the spatial graph. Just before starting this topic, I want to presenting a new. What's the new things about to when the workshop started? Oh, there are the past chats. Okay.
Yes, that's okay. I'm answering the chat. Yes.
Yeah, okay. So let's getting back to the PowerPoint. And let's just. Are you okay if you want to trying file together to creating a graph based on the plan and open it in the grasshopper together to make sure that everyone is okay with it? I'm preparing the folder sample plans 3 for you, and if it's okay, please open it and creating a CSV file from the relation that you can see within the plan, and creating a graph with, by it, and we are going to open it in the grasshopper and use it in the next step to creating a spatial graph with it. So if everyone are okay, please opening the sample 3 file and trying to creating a CSV file in the same format I provided for you into past examples.
Can you please share the files with me? I'm sorry, I'm too late, but I got confused from the time zone. So if you can share it with me, that would be fine.
Okay. I will upload it to you.
Yes, thank you. Okay.
You're welcome. Please open up the folder graph and space syntax sample plans 3 step 0. This is a plan here. So I want to please creating a CSV file based on it, and creating a relationship as you can see in this file, and then we're going to open it in the Grasshopper and going to the next step and create and reforming and recreating this plan with the Termite-Nest inside the Grasshopper.
Okay.
I just want to speak about this plan. As you see, there are some indexes in the plan that showing what these places are about, and we have this table that shows the relationship or connectivity pattern. The indexes we have in the first column, the second column is about their names, their area, which we told it's not important in this stage, and then we have their relations. And how you can find this relation you can find it by looking at the plan. For example, the space with the name 0, it has a connectivity with 1 and 6. So we write here, relationship is 1 and 6, and also for other spaces, for example, for space number 4, it has just connectivity with number 2. So here 4 is just with 2. And in this way, you can complete the table in the Excel file, and then you upload it in Grasshopper.
And about the index also, as Carl asking, the index in the Excel is not equal to index in the Grasshopper. You started from the row 2 in the Excel, but Grasshopper counted as 0, 1. The first
Yes.
became the first index in the Grasshopper list.
Yes, because in Excel, the first row is 1, and then the second row would be 2. So instead of starting indexes from 0, we have it from 2. And then you should consider this in new indexes, which are indexes from Excel file, and write it here. For example, this is 2, and this space has connectivity with number 3 and number, I think it should be 7. Yes. This is the difference between Excel file and showing this in here.
Okay. We said that in architectural design, we consider in the earliest steps of design process, we draw the bubble diagram and connecting spaces together with lines that represent the relation between the spaces for us before we are starting to sketching the plan and creating the layout and geometrical shape. So if you want to presenting and make it understandable for machine, because this is a cognitive way of thinking, when we connecting the spaces by line to each other, we need to creating a metric value for our linkage and linking of the space, and make it an understandable for machine to calculate and for analysis. So the methodology we use is a space syntax, which is a space configurational analysis tool, and it's required graph to calculate the space relation and make the space hierarchical for us. So in DSP, and what is really important here is creating a graph and how we can create the graph. This is exactly what you're doing now, and creating a graph from the plan. In the graph, you represent each spaces as nodes and vertex, and the relation between the spaces as the edge between these two nodes, and the metric you use to connecting these spaces is really important and could be varied based on the topic of the design and the design purpose. For example, in the plan housing, the example I provided here for you, you just use the direct interrelated door with two spaces as adjacency and related space. And if two spaces have same door, which is connect them directly, we consume these two spaces as a related space. And this metric value could be different in different in other plans and different functionality. For example, in the schools or in healthcare and other or industrial design. In designing industry, it could be as the facility exchangement, the participant exchanging between two spaces, and the time that it needed to going from one step to another step. Actually, in the healthcare design building, we calculating the spatial relation based on the time. For example, we said that if we want to go from space I to space J, we should spending less than 15 seconds and calculating the relation between them based on that. So here we just using a very simple way as a direct related relation with the door, and trying to create a graph based on it, and creating a space syntax and analyze it with a space syntax, and to measuring the functionality of the graph. And we talk about how we can represent it inside the plan here. And we can record it by using different spaces and generalizing the heat map, generating the heat map, which is show the functionality of the plan for us. So after that, we're going to talk about much more how we can turning this provided information and use them to generating a spatial formation and geometrical and coming to the geometrical phase. Before that, we want to make sure that this part is understandable for all of us, and we are easy with this part. So I'm waiting to see one of the results of participant to continuing my work.
It's with my one, it says for the graph maker, solution exception, local variable all points, graph before assignment.
Can you see my screen?
Yep.
Yes.
Just about the question Carl has. In creating the relation file, which is really important, is the degree of the abstraction we use to creating the relationship between the spaces. For example, if we want to categorizing the spaces in the different parts of from a scale, we have big spaces here. And in the medium scale, we have the rooms like this there, and also we have some sub rooms which are being sub branch of the some spaces which are really small in scaling. We can handling them as considering the whole things together here, and trying to divide them after generating the space. For example, we know that this is a kitchen that have some subspaces within itself, but they can be considered as one space in the first look and the first level of abstraction. And we can consider them as a whole thing in the first subdivision, and then after we creating the space plan and a spatial geometry, we can subdivide it into different parts. Let me just show you the example that we have here. Here's the example we did in one of our project. We firstly just subdividing this parcel or boundary in the larger scale, and then trying to do it recursively in each of them to creating these subspaces within it. It's exactly where we should choose the methodology to subtracting these spaces and to make it much more efficient. And this is exactly what we're going to talk about in this lecture, in this part of our webinar. And this was a really good question, and this was a really good point, and we are going to talk about it much more in the next chapter. We talked about the space syntax graph and doing some examples together. We got lots of rows, and one of them is not solved yet, and we're going to solve it. So in this chapter, I'm going to the point that we mentioned about the degree of the abstraction we're trying to inputting the relation between the spaces is exactly where we are going to talk about here, and continuing our topics. So in the computational design process, we said that if we want to automate the design process, we need to understand how we can make the quality variables understandable for machine and converting them to the quality to quantity values, and to make to do analysis upon them. And this is exactly where we have two different phases, and we're going to clarifying these two phases. Layouts, our plans are generated in two kind of ways: the exhaustive and the non-exhaustive ways. In the exhaustive way, we are trying to in this example, a Termite-Nest is work on the exhaustive way. Exactly, we're trying to generating different shapes based on the same topologies that we created from in this step. We can see that how we can extracting the topology pattern from the plan. So we are going to generating topology by our imaginary and our desires in the next step, and trying to generating spaces from the provided topology, checking this quality, and evolving them and put it in the loops or evolving them. So there are lots of efforts in the automation and generation in space planning. The thing which is really important is that this is not exactly the process that a good machine do exactly in a one way. It needs a collaboration. It needs interaction in some steps, because as we talked firstly in the morning lecture, the creativity is the main point in the architectural design problem. So we are going to talk about, we are now going to subdividing the design process into different phases. We generally say that design process in architectural meaning, we have three-phase: analysis, generation, and evaluation. So now we are going to subdivide it much more in detail, and telling you how we can use machine in this process and collaborate with machine in this process, and how can we exchanging data with machine and getting the output from it, and relating the subdivided parts together to make the whole design process. As it's represented here, you can see this is just like representation of the space relation, as you did in the last assignment file. It shows generically how we can select the space, and clarifying the related space to the specific point, to the specific space we are trying to create the relation for. So this is a massive quantity of data, and the calculation of this is really hard. Just as you have question about how we can solve the interrelation between around the question in the last file. Sometimes it's really hard to calculating the and make the relation between the spaces numerically. So we need to understand how, and it comes from the experiments. And if we are going to see the result of the numerical value we provided, so Termite-Nest also aid us in this process. We can create different numerical value from the provided plan, and checking the result in the geometrical shape, and reboosting our quantitative creation data entry, and making the plan qualitative space relation into the numerical values. So the design process actually in the automation of the design process, we have the as we said, this is not a one-way procedure. We do not put all things upon the machine and tell it to do everything for us. It's not really possible in the generation of the complex task like the architectural planning. And we are going to talk about how this interaction could be possible. This design flow chart represents that we are in the Termite-Nest methodology. We're creating a knowledge source here, which gain the data from the user, trying to create the data based on it, and trying to enhance the information and creating actually getting the data, analyzing them, and creating new information from them, passing them to the new steps, and getting the information back from it, and also and then the repetitive process make the whole automation for us. Okay, so in the first step, as we said, as the architect have in their traditional way, they need to creating a physical program for themselves, which contains the name of the spaces, the relation between them, and the size of the spaces, and their central and some other information like this. So And we did this together in this step. So this is exactly the analytical phase, and here you can see these parameters that are gained from the users in the process could be subdivided in two categories. First is about the internal spaces information, which is as the Excel file that we have and the assignment we did together. The other parameters could be named as the context. Excuse me, it's just checking the participant, I guess. I missed the question here. Okay. So the important part is the context parameters, or the parameters that are not interrelated to the spaces directly, which could be as the boundary shape, the neighbors, the orientation to a specific desired light, for example, which are not really mentionable in the physical program, but they also have indirect effect in our spatial configuration and planning. So if we want to make it much more clear, we can subdivide them into this chart and representing the relation and interrelation between these parameters. Here we name some context parameters as access point, friendly neighbor, boundary shape, and unfriendly neighbor, and also the internal parameters as space relation, spatial, and adjacency. So we talked about this part, and we do some effort in it. And now we're going to say how we can integrate this parameter in this with these parameters, and where exactly this happened, and which phase we need this relation. So as you input your internal parameters to the knowledge sources we said here sooner, these two steps are be done by the machine, and it provides some information based on the syntactic analysis and graph analysis, and giving back some information to our knowledge resources. So this is the first interrelated part, and in the next step we use the output of this information to creating the spatial graph. This is exactly where we need where the collaboration is started, and the external parameters are being combined with our internal parameters. So here are some diagram that represent this to us. For example, as you can see, this is a spatial separation of different spaces in the environment or in the CAD environment, and this is how the formation changes. For example, let's just say it in this way. So if you think this space hierarchy and spatial configuration, you know that space 1 should be adjacent to space 0, space 6 also, and space 2 should be in a way that interrelated with two spaces. So it could be adjacent with two spaces in different formation based on the geometrical space, based on the spatial configuration. It depends on lots of parameters. So it could be located here against beside these two spaces, or here or here. So how can we exactly defining the base space or location for it is the problem that is we are going to talk about, and it's come from this external parameter relation. So this parameter aid us to find and defining a specific location for this space in the adjacency and spatial configuration. So let's just opening some new files and working with this spatial graph and show you how this works. Please go to the spatial graph folder and opening the sample plans 01, step 2. So when you open the file, you will see the definition like this. You all have this. It is okay. Okay, so let's just disable the step 1. We did it by the time and understand how it worked. Let's go to the step 2, enabling this definition, please. So we are now using another component from the graph network, which is a spatial graph. A spatial graph is where we are going to combining the internal parameters relation with the external parameters, and this is exactly where the boundary of our the geometrical phase taking place. So for this, we need to firstly understanding the accurate area of the boundary we are trying to draw our plan within it. This is actually the area column are used. So before we drawing the boundary, we need to understand exactly how much space we need. So we can use mass addition to see that our department, our plan needs 230 meters square space. So I am drawing a boundary that contains this meter within itself, because if it's not okay, you may not gain a good result. So this component contains some input variable. I'm trying to describe it to you here. The first parameter gain the inputted boundary. I draw a simple rectangular here. And the second one is the point topology, which is come from the space syntax. The space syntax, as we said, trying to creating the hierarchical and organized space hierarchy for us based on the graph. So this is a topology that came from a space syntax, and our spatial graph doing its process based on the output of this space syntax topology. The other one is the target. Target is the guide of the spatial formation that's come from the space syntax. Space syntax provides this information, which is actually about the spatial formation and the measuring of. It's helped the spatial graph to measuring the actual space that each space need. And locating the point which representing departmental spaces within the accurate scale in the boundary. And the two other, the reset is obvious. The start point and end point is exactly 2 points that aid us to control our graph within the boundary. As I change them, you can see the graph change within the boundary, and they are representative of the entry of the space, and the other one, which is named as the endpoint, could be the last index or last department which we want in our plan. For example, if we drawing the school, for example, we may have the entry and the exterior way exit door, so we can put them here, or it could be also used as the graph controller, which control the specific index location. Yeah. So, and the start point index, endpoint index is very assigning the specific space to the point we draw here. For example, I assign the index 3 to the endpoint. So if I connecting the panel here, it shows that garage is the space 6. So if I change it to space 5, you can see the graph change, and it's trying to attracting the space 5 to the endpoint. Let me just draw the name of the spaces here. As you can see, the number 5 came here. Oh, excuse me. Okay. And the other part is the department area, which is get the area of the department to calculating the distance between the spaces in the real scale based on it. And the iteration steps is where the loop is started. Let me just display, explain the methodology that it's used to work to make it better, to make a better understanding about how it works. Here, as you connecting your topology and target to the spatial graph, and defining the specific boundary for it, it's trying to generating the spaces in the accurate location. So, but by the time it does not have any conscious about how could spaces generating exactly accurate beside each other. So it's start randomly and generating some random points in the space, and once you iterate it, you can see that it's trying to arrange them correctly based on the relationship. Is it clear? Okay, so if I change it and try it, you can see that it's represent the other shape of the arrangement for me. And as I changing the seed, also it change the space configuration within the boundary. So this is a basic space configuration phase and spatial graph formation. So, and I want to let you, if you have any question, ask about this phase to continue to go further. Everything is okay? Okay. So we're talking about the spatial graph, and we say that how it works and why we have it in our Termite-Nest. This is exactly where we can combine the external parameter with internal parameters, which are come from the analysis, and this is where the architect can use its knowledge in space formation. It uses machine to analyzing the physical program for it for him, and calculating the space relation, and visualizing it in the CAD environment, and it lets them to combine their creativity within the spatial configuration, and it provides some functionality for it to controlling them. So let's just take much more go much more deeper. Does anyone has seen the example file in the Termite-Nest? No, nobody does not checking the Termite-Nest example file in the Food for Rhino. Okay, in the Food for Rhino example file, we briefly representing the whole process of the Termite-Nest. So if we want to show it, it's exactly some kind of excuse me. Okay, it's okay. If you want to explain it in this graph type and this flow chart, the definition that we have is exactly work as the flow chart we explained. Here we imported data, we're analyzing it, internal parameter, and now we are talking about this phase when we trying to use a spatial configuration. So okay, I talked about them. Okay. So this having a representation from it. Something we're going to get definition and the zoom video. Yeah, you have the definition. I uploaded in here, and also the definition is existing Food for Rhino. Okay, let's go a little further. So here. So here we are generating the spatial graph, and now we are going to show how much space they are occupied by themselves. So, and this is exactly where represents something like the bubble diagram we have in architectural planning. And as you can see, the component bubble diagram, we are going to draw a category here. This is a simple model of the generating process. We are going to make it much more complex in the further task. The bubble diagram use exactly the boundary we start our formation as get it as an input, the result of the spatial graph point location, and trying to generate space around them based on the area. And the BIOS, which is defined here, is a point which is really important, that we can change the area after reading the data. For example, you enter the data here and you produce the area for yourself here, but after the spatial configuration, you need to change them because you want to see the differences. And also it's really important in the spatial computation geometry formation, and it plays a really important rules in that steps, and we just want to talk about it a little here, and we talk about it in detail in the next phase. The BIOS range are always between 0 to 2, and they controlling the area accuracy after the spatial configuration generate the spatial graph for us. And as you can see, we can change them. For example, I want to change. You can see that this space got lots space, and it's actually determining the other spaces. So and the so this is let's talking about the generation process right now. So we know the exact meaning of the generation. When we talk about the generation, it means that based on the same topology, we're gonna achieving different kind of formation and shape generation. So these provided parameter aid you to generate different kind of spatial form generation. And also Termite-Nest also have a component which is the Termite-Nest core. Nest core is some kind of the auto adjustment component that if we run and if we run it, it generates different form of a special formation for us and representing it to us. I'm going to check it out for you. I'm connecting the panel here to it. The message shows here says turn the auto-nest on to start nesting automatically. I'm connecting the Termite-Nest boolean to it and turn it through. As you can see, it said resetting the diagram. I'm resetting this, and you can see that it's trying to generate different shapes based on the inputted data. So what is really important here is this generation and this generated spatial graphs are not all accurate enough to consider as the best solution. These are just some generated forms which comes from the adjustment of the parameters, and we can selecting from them if you're recording the output of the generation. It provides a solution space for us to saving the different kind of generation. For example, let me just disable in this step, and I'm going to okay. I'm going to recording the graph generation. So as you can see, it's actually creating different types of the geometry for different types of spatial configuration recorded within itself. And we can choose different spatial that can be assigned in this specific boundary. And we can change the boundary and checking the relation of the space or geometry shape on the spatial graph. And this kind of analyzing tool, I'm changing to the circle, and you can see that the spatial formation change based on the geometry change. And even if I change it to the L shape file, excuse me, you can see it's trying to configuration the spatial graph within the defined boundary. I don't know why I can't select in this point. Oh, here it is. The recorder is on. So, as you can see, so this thing is really important here is that the start point and the end point which we defined in the spatial graph can actually creating the direction of the our final layout. It's some kind of it can show us when we change them, we can see that the density of the shape can change within the specific boundary. I'm move it here, and you can see the most of the part of the plant trying to shape themselves up on the top side of the boundary. And when I change it, I can change the density of the space separation between the boundary. And it's really helpful, and it's really upon the designer desires to change them and shaping the desired spatial space separation based on the goals it follows. So let's do you have this file open in front of yourself? So is it work clear and true for you? There's not any question here. Where is the delete button? Okay. So, as you can see here, in the last definition, we have another component, the layout generation component, which trying to generating the layouts based on the bubble diagram and make these bubbles in a regular geometrical shape. So this is not really a good space generated geometry, and it's because of the spatial graph separation in here. So you can see I can control it. I can controlling the space compactness and formation based on the controller I put here. So I want to ask you to trying to generating a space shape uh, from the loaded CSV file to generating a plan like a plan which we extract this information from a plan sample plan 001 and checking how you can control them to generating the plan with.
Sorry, Mohammed. Did you? Could you explain that one more time?
Excuse me?
Could you please explain that one more time? You wanted us to generate a plan. Yep.
We extract the information from the sample file plan 01. We load it in here. We creating the space syntax for it. I introducing the spatial formation to you, and you know that how can you control the graph within the boundary. This is the bubble diagram that is generating the space size for you, and the last part is how you can generating the regular geometry shape based on it, and you can see that you can change them to create a much more accurate shape. So I want to ask you, please doing it by yourself and trying to generating a shape like the plan we extracting the parameter from with the definition here.
Okay, thank you.
Mohammed, I have a question. Can you please again explain in the spatial graph component, what does the start point and end point inputs does, or what does they mean?
Okay.
Thank you.
It's fine. Let me just explain it in here.
Okay.
Let's see in this recorder. Okay. So, as I told, spatial graph trying to show you where exactly where is the exact location of a space in the real boundary size. So the start point and the end point are just some kind of a controller that you can control your graph direction within the desired boundary. For example, if I choose the entry here, I want to put the entry in this specific point here. I put the point here, and also I want to, for example, setting the garage as an end point and locate it there, and locate it there. So after setting the location for these desired spaces, I need to defining the space indexes for a spatial graph to know exactly what space I am mentioning to. For example, to understanding this, I'm using the department list here. So I want to put the main entry here. So I should specify the index 0, which represents as main entry, as the start point index, which is being related with the start point. And also the end point, which I want to assign as the garage, which is the index 6. I put it as index 6. So I assigning the boundary for it, and you can see that it's drawing a spatial graph in a way to locating the entry point near to this point and the garage near to this location. If I if I visualizing the index number here, you can see the number 6, which is the garage, is trying to being connected with this location, and the main entry comes in here. So is it clear?
Yeah, I find them like contextual anchors of these spaces where I want to pull them in the position of
Yeah.
all the of all the perimeter is where they want to be. Is there a way to put more than two starting and ending points, so I can make a more specific diagram?
Excuse me, I didn't got you well.
For
I
example,
didn't understand.
is there a way that I can anchor or pull more than only one point into the graph, so I can
Yeah.
control more?
Yeah. We are going to talk about it after this in the more
Okay.
in a diagram with more spaces. We have components that could do this anchor and attraction forces for us. But the spatial graph individually providing these two anchor for us.
Okay, it's clear now. Thank you.
Okay. Other participants are also following us. Please write it in the chat if you have any question, if you are shy to ask it in the video. I want to make sure that everyone are getting the same understanding from the webinar. Please please update me with your state of achievement from the webinar right now. How is how it is going on, and is it okay? Everything is clear or not? There's no reaction.
I think we can speak about more interaction in spatial graph and the plan generation for tomorrow. Maybe for today, this spatial graph and 2 points for a start point and end point. This interaction would be enough for today, I think.
Yeah, I want to make sure that everyone's got the process well, because we weren't going to much more deeper and talking about complex problem and complex design planning, which I think it's make it really hard if we want to talk about it now. We talk about the space syntax and graph. I want to ask you, please do this assignment and do the example files and struggle with the problem that may you face with to make sure we all have the same understanding about the process to continuing and go much more deeper for tomorrow.
Yes. And
Okay, so
also, I think. Okay, go on.
I'm sorry. No. Please, first go.
Okay, I just wanted to ask you, Mohammad, to make a summary of this code. Maybe I saw one of the participants said that it's a little difficult for them to make the plan generation. Maybe it would be better if you make a summary step by step what happened at the first, bringing the CSV file, the next part, the graph, the space syntax, the spatial graph, and up to plan generation. It would be better if you do it.
Yeah, it's okay. And Ahmed Hassan asked about that. It's really difficult to make the original plan. So this is exactly what I want to show to you. To facing this difficulty, and I'm telling you how you can tackle this difficulty in the next part tomorrow. Please, I'm just saying briefly what we have done by the time, and talking more about these specific components about generating the layout after that, and mentioning two important notification or something like this after that. So the main things we want to understand today was that we can extracting the information from the drawout plan, and we can represent them numerically, and understanding how we can abstracting these qualitative variables in numerical way, and understand. My bubble diagram doesn't work. I will check it for you. What is the problem with the bubble diagram?
Hi. It says solution exception iteration over known sequence of a type R curve.
Okay. Please just checking your iteration steps. When you this is a beta file of the Termite-Nest. It may have some error like this, and this is because of the target of the bubble diagram. When you face this error, it means that your spaces are not integrated or not compacted enough. You can change the shape boundary or the origin point, or changing the iteration steps to solving this problem.
Okay, I will check it, and I'm gonna let you know if it's correct.
Okay, it's okay.
Thank you.
So I'm just saying that so these things the things we want to know in this two-day webinar is you can use the space syntax and graph analysis not just to use for Termite-Nest to generating the design and plan for you. You can use this space syntax component for analytical phase and to and it's just depending on you how you can use it. It's a really powerful tools, and we creating samples that represent to you how you can measuring the relation of your spaces with these graph analysis and space syntax tools. And for example, if you want, you can implementing this analysis on different plans and getting the results as the analysis of how different plans with same program, the physical program could have different pattern of relations, and how this change the integration level of the spaces. And if this topic is interesting enough, we can talk more about it in next days. If you doing effort for it. And also in the next part, we talk about the spatial graph and talking about the internal and external parameters and how we can combining these two parameters together with the aid of the architectural manipulation and human-machine interaction. This is where we can you can cooperate with machine to generating a spatial graph using the knowledges come from the analysis and put your additional information about the geometry and external parameter to it, and to generating these to locating and configuring the spatial separation. And this is not exactly the whole things about the spatial graph. It's just a simple task. I just want you to do this sample files to being familiar with it, to can show you how you can linking this spatial graph with the evolutionary process, the genetic algorithm, and how you can connect it to the genetic algorithm to find the best parameters here for you to generate the spatial formation, spatial graph for you. And it really depends on different parameters, comes from the external external parameter named as geometry, the neighbors, and other ones. And the bubble diagrams and the layouts also are just about the geometry shapes and the geometrical phase. I just want to adding some information about the BIOS and the layout at the end of the today. And if everyone's okay, I'm going to talk about it. Yeah.
I think,
So,
Roberto, you had a question before.
I just
Is it
forgot
solved,
what I
or-
was. No, I just forgot what I
Oh,
was
I'm
question. I'm sorry.
sorry.
I'm sorry about it. I
No,
didn't
don't
understand.
worry. I'll try to get it again, and I'm going to ask you for
Okay.
sure. I'm sorry.
It's fine. So the BIOS, which is here, can you have your you remember your question?
Yes, I remember the question.
Yeah.
How close would you say that the final result of the layout is to the programmed areas that you're configuring this? I don't know if you get my question. I don't know if I'm doing it right.
In this specific example, or you ask it generally?
Yeah. For example, here, because I'm measuring the areas of the final layout, and I'm trying to match them with the areas that are programmed in the CSV. I find them close, but I want to know how much do you think it's close, are close those areas. I don't know if
Okay.
you get my question.
Okay, no, it's okay. Actually, this the generated layout in the final step is not 100% accurate with the number you put as the entry parameter. So because it really depends on different parameters. For example, if you're changing the geometry or the graph inside the shape, you may reaching the different areas. Because of the packing of the spaces together within the boundary, and also the methodology that Termite-Nest used to generating final layout is based on the voxel-based design.
Okay.
And the voxel-based design is a discrete modeling, which is not in a fuzzy way. It really depends on the threshold here. I will talk about how we can make it much more accurate and make it to nearest as possible to the
Great.
goals of the area.
Okay. I'll wait. I'll wait for that. Thank you.
Okay. It's fine. I'm just talking about the BIOS here. The BIOS which is here is not necessarily, we are not necessarily have to change them to reaching the BIOS also, as Roberto said, it's some kind of the answering to your questions. That the bias is provided to controlling the area of the layout in some way. So if you're changing them, you can see that the size of the area are going to be increased and decreased. And as you can see, the size of the specific space may have effect on the other one. So if I growing the size, growing the specific space size, it can occupy the it occupy the voxel which is used for this space, and they are going to compete for to having the space. So it needs to changing the spatial formation to get the other space for itself. So it's just like a recursive process to reaching the accurate position and accurate area for each space. Could be set in an evolutionary process, and using algorithm to aid us to find the best parameter for the bias and space allocation. We're going to talk about it tomorrow, to how we can set the best spatial location and bias to generate the accurate size for them. And some also maybe in some program, Termite couldn't exactly shape the best area as means of the size of the area, I mean. And this is because of this is the first release of the Termite-Nest. This is a beta version. We are going to this phase is actually under the progress phase of the Termite-Nest. We are using different part of geometrical shaping for this, and we are trying to make it much more robust in our future works. But by the way, it works well for treating the shape. And I'm talking about the bias. It depends on the number of the spaces, the geometry, the complexity of the boundary geometry, and the relations of the spaces. If there are two integrated relations between the spaces, so the finding the accurate bias measure is really hard, because each spaces are trying to find a specific area and competing with other ones to find the best location and area for themselves. And this is exactly where we need to controlling the spatial graph to find the best location for it too. I will talk about the option, the controller that aids us here, which is here. This controller aid us to controlling the spatial the space location that work with a spatial graph and aid us to controlling the graph and the space separation between the boundary. We'll talk about it rules and how it works tomorrow, and trying to building a plan together in different scales and different shapes, and then going further to it. Okay, so if you have questions, go ahead. It's okay. No question. So I wish you all enjoying the 2-day program and find it useful. I hope it's really. I hope it's being useful for you and joyful. And I will see you tomorrow. And if you have any question, I will be here to answer it.
Cool. Thanks a bunch, Mohammad.
Thank you very much, Mohammad.
Thank you to participating in our webinar. Thank you.
I think one of the participants have a question.
Yeah, okay. Which one, please? Bypass change area, but we have area at Excel sheet. Okay. About the question Ahmad has about the BIOS and controlling the area. Maybe I'm not describe it clear. That's because of the methodology that Termite-Nest used to generating the layout and generating the spatial configuration. The area that you provided in the Excel file is used in the spatial formation to generating the probably accurate position for spaces within the boundary. So maybe the calculated phase have some inaccuracy during the calculation, which is come from the high degree of the interrelations and the shape of the boundary, or the wrong inputted parameters. It depends on really various parameters. So we put it here to make a controller for you in the final step to controlling the final generated layout if you find them inaccurate, so you can control it to make them much more near to your goal. So okay, Carl asked about the assignment is set up with sample plans 03. Actually, we have the assignment about the generating to creating the space relation for the sample plans 3 in graph and space syntax folder. And also the other one is to trying to making the jump to plan near to the plan which it is data extracted from, and I've actually forgotten the assignments all. I need to checking them folders.
I think you did completed the results. Yes, it wasn't assignment. You explained them. Yes.
Excuse me.
I think you completed the assignments yourself. are there also other assignments that participants have to complete themselves?
No, we don't have any specific assignment that they should prepare for us for tomorrow.
Yes.
I'm just you just have them to work with the
Yes.
assignment that you should prepare for us is for the day 3 that you will trying to creating a whole project by yourself, and this is your actual assignment. There are just some sample files to be integrated with and to find the struggle parts, and if you face any difficulty or a problem, come and we're trying to tackle it for you.
Yes.
And please,
Please, yes, okay. Please,
I'm just
everyone, review.
yeah. Okay.
Yes,
Okay.
everyone, please review the codes and what we told you about today. And tomorrow and also the third day, we will have assignments for you that, as Mohammad said, you have to complete the whole process by yourself, and exactly we are here to help you by them. Okay.
Great.
So,
So tomorrow at the same hour?
Yes.
tomorrow at the same hour.
Great.
And we have also sent the assignments to our audits. They can also use the assignments that have been sent to them by email. And if also they can have questions, maybe they can write under the YouTube channel. We can also help them by that.
Okay. So if there is not any question, I will say goodbye to you all and have a nice day.
Thank you, Mohammed.
You're
Thank you,
welcome.
guys.
Thank you.
Nice to
Thank
meet
you.
you.
Thank you.
Thank you very much. See
Thank
you
you
tomorrow.
all.